you. So hello everybody. Very nice to be here. First time for me in Finland. I'm Sam van Houten. I'm a CTO at Codit. We're based in 6 countries in Europe, where Belgium is the headquarters. We're around 120 people. And I'm a fourth year Azure MVP. I started with integration, but now switched to Azure. And I'll be talking about IoT on Azure, and more specifically into the industrial IoT scenarios. I've been doing quite a bit of IoT with Azure recently. Work quite a lot with the product teams as well at Microsoft, and most of our customers are indeed in that industrial space. So we don't target too much. We have 1 or 2 customers in the consumer IoT, but most of the the customers with the bigger projects that we have are in industrial IoT. So I will be starting a little bit on and explain how we see industrial IoT and specific settings and scenarios for industrial IoT compared to the other solutions. And then I will talk about the different phases in the project, how you connect and so on. And of course, I will do a mapping every time with the Azure IoT technology, because after all, this is an Azure user session. And in the end, I kept all the demos for the end. So I have quite a few of these demos, mostly targeting IoT Hub. And you will see, a lot of details in that. But first, to get to know you, who has been using or at least playing with Azure IoT services? 5, 6 people, so that's good. So it's not intended to go very deep. I will be talking mostly on the higher level scenarios. So first of all, I try to categorize our projects into the 3 things. And the first one is, of course, consumer IoT. And I think most of that is, gadget oriented. Of course, you have the smart thermostats, you have cars, that's pretty much adding value. You can argue about smart toasters, about smart teapots, about even the hair comb that was telling you how well and how bad your hair is. I don't think there's, for every one of those, a real business need, but having, gadget freaks can be, a business model as well. And then, of course, we have public IoT. What we see there is things that are in cities, for example. We can talk about crowd control, so where you can just track people based on, for example, mobile phone or by camera movements. Of course, energy, think about wind, solar energy, and waste bin, things like that. So that's typically in a smart city, smart environment stuff, and you have all these things outside in the field. You don't have all of them combined into one building a lot of times. Parking sensors and so on is very common. And then the industrial IoT is, of course, totally different. What we see there is that most of the time you're located inside a plant. All the devices, and sometimes these devices are pretty high, pretty big, they're all part of, installed in a plant. And that makes things sometimes much easier and sometimes much more complex. And that's what brings me to the next slides, where we say, okay, if you see consumer IoT, so think about these gadgets and so on you have at home, what you will see is that the cost per device can sometimes vary very much. If they just smart enable an existing device, it can be that they don't want to add a lot of value. But if it's a gadget as such, a hair comb, right, can go from 10 euros to 60 euros. The only reason why you would buy it is probably because it's a gadget, right? So if that's your target, then the IoT component for that device, it doesn't matter that much, the pricing aspect of that. What we will see, I will be talking about gateways quite a lot, is that in IoT scenarios that are used by consumers and in the homes, typically you don't have a gateway. You cannot say, hey, here's the comb, and by the way, you have to install this piece of hardware to make sure that the GOOM connects to the cloud, to the internet. Very often it's wireless, it's battery powered. Of course, if it's a smart toaster, you can use the net power from that. And you have a lot of diverse connections. Sometimes you will connect through a mobile phone using Bluetooth. Sometimes you will connect using wired connections. And most often you will connect just using the Wi-Fi connection at people's home. That makes things sometimes complicated because you don't control these Wi-Fi connections all the time. And you have to make sure that these things are pretty well tested. And what we see around integration scenarios for customer and consumer IoT, a lot of these are using scenarios like if this then that, where you can just use the ecosystem and say, okay, if my hair is no longer, healthy, then I want to get an email, or maybe I want to post it on Facebook, so whatever. So not the most relevant scenarios there, I would say. And then we have the public IoT, where you often have a lot of devices installed in an independent fashion. If you think about waste bins in the city and you want to monitor those, or think about, glass containers, you want to have those monitored. That's a lot of different devices, and these devices are most of the time not connected to any power or any network. So they have to have an independent component where the cost can be very variable. If you talk about a waste bin, you probably don't want to add 300 euros just to get that waste bin connected for your smart city. But if it's a glass container, that could make sense. So the cost really depends there. Gateways will only happen in what we call clustered installations. So it could be that you have, for example, windmills. If these windmills are combined together, often you will see that at least there is a local gateway that connects the 10 or 12 whatever windmills in that park, and they will transport the data into the cloud. The good thing is that you always control the connection from the device to the cloud if you install these things. So that could be low band, things like Sigfox and so on. Or it could be your proprietary protocol, because you control the device and you typically control the installation of these devices. And a lot of times it's just about telemetry. Okay? So we will leave these scenarios aside because we will be talking mostly on the industrial IoT. And what we see there is that the cost per device can be quite high. If you talk about the machine that is producing, real manufacturing things, there you talk about hundreds and sometimes millions of euros for a machine. So adding costs to those machines of 1,000 euros, for example, it's not such a big deal in a lot of cases. Of course, everything varies. And what we see is that the gateways are very commonly used in scenarios in industrial IoT. So if you have a factory, and you have a lot of machines, a lot of lines, a lot of times they will connect using a gateway, and that will I will be talking about that later on. Batteries is almost never the case, at least if you're inside the factory. Bless you. And it's a very solid connection most of the time, because you can talk with the customer, and you can wire these devices to the cloud. But a lot of times what we saw is that you still have network restrictions, because it's enterprise customers. They really care about security and also typically use the traditional network security. So you have to make sure that you use the firewall rules. We have had gateways that had to go through a proxy and so on. So these things are not the case most of the time if you own the total solution like the consumer IoT. So that's a very important thing to tackle. And what we also see is that, especially for machinery that is actually legacy systems, all these legacy systems already have a lot of data. And a lot of times they have local protocols and all send that data. You don't want to send necessarily all of that data into Azure, cost-wise, data storage-wise, and also performance-wise. So what we see is that we very often need to have some what we call edge filtering. So where you will maybe only send the differences to the cloud. If the temperature of a certain machine doesn't change more than X%, for example, you might not send it unless maybe every hour or something. So that's really cases where we are looking also at at gateways for this. In the industrial systems, what we see is that the variety of systems, protocols is huge. You see all these different PLCs, all these different hardware systems, and all of them have their own proprietary protocol. The good thing is, if you see the last bottom of this, the last block, OPC UA, you might be familiar with that, but that's a standard that the industry is really, especially the German manufacturers, they are really putting a lot of effort into that. And that will make sure that, hardware or machines from one vendor and another vendor should be able to talk to each other. And also, if you look at what the Azure IoT team has been doing in Germany, the team in Germany there, they have been building OPC UA connectivity towards Azure. So now companies are capable to have commands from IoT Hub sent directly into the OPC UA enabled devices. And we can see that the new devices, the new machines coming into these manufacturing scenarios, more and more they have OPC UA capabilities, and that will make things much easier over time. Pretty important is that you have a concept of multi-tenancy if you talk about industrial IoT. So the customers where we talk or talking with are building the machines, and they are selling these machines to multiple customers. So our customer has hundreds and thousands of customers where they will deploy these machines. So they want to have data insights across all the customers, but it has to be anonymized because otherwise their customers will not trust that. So they have to have anonymized access and be capable to say, okay, hey, this machine is behaving in such a fashion when it's outside, for example, and it's behaving in a different manner when it's inside. So they want to collect data and learn about their own machines, about their own maintenance processes and so on, based on the conditions at the customer. But of course, if you provide insights to their customers, yeah, that has to be isolated. So there you have multi-tenancy. And that's an important aspect if you come back to the data later on, is that you have to make sure that you can get access across tenants, but you have to make sure that the access or the data providing the data to the end customers is really having a good security. And that's an important aspect as well. And if you then talk about the scenarios that we mostly see in the industry, it's mostly about remote monitoring. So you want to know what's happening. You want to see if something fails because you want to have immediate action. You also, and that's the second thing, you want to have predictive maintenance. So we have one customer in Belgium that is producing things in plastic, and they had too much, downtime on their production lines, and most of the time it could have been solved just by monitoring the things in an automated fashion. Now they see it, they have the data, but they don't look at it because you know how things go. No one goes to the dashboard and presses F5 every hour, but if you get the alert on the right time and not 1,000 alerts a day, then you will typically act on that. So we also want to prevent to send too much alerts, because what happens then, they create an Outlook filter and it gets ignored. So that's a very important aspect we see there. Now the different phases or the different stages in an IoT project are pretty common. So of course it all starts on the left with the devices. That's the hardware, that's the battery, things that come into place. Most of the time we don't want to get involved there. We talk with partners and make sure that we can start talking how they can connect their device into Azure. And there's 3 connectivity options that I will be talking in the next slides. You can go direct and you can go through gateways. And then of course at the ingestion point, that's where you will start getting all the data into your cloud system. That's where IoT Hub has a very big role. That's where they started with, and that's based on Event Hub. I think we will see on Event Hub later tomorrow by Dan. But it's the same engine that can ingest gigabytes of data in 1 second if you need that. Of course you will pay for that, but it scales pretty big. Then of course you have as soon as you have the data in the cloud, you did not provide any added value to that customer. You just have the data ready. So the 3 last blocks, that's where you start to do the real interesting stuff for these customers. So you will start looking into automation. So you have business rules, alerting. You will be able to send back commands in a lot of cases. What we also see, to be honest, is that a lot of customers don't like, at this stage in their IoT projects, they don't trust it enough to send automated commands back into their devices. They need to build trust in the system and in the decisions of the engine before they will allow that to make decisions and change physical things into their factory. So most of the times, what we start with is doing that calculation and giving the advice to a user. And we say, maybe you should turn off that machine, or maybe you should increase the temperature, or just figure it out. And he can still have a human validation based on his experience and so on. And then, of course, that's the activity, the automation. Then you have the analytics. I think the first session of this morning was pretty good in that, where you can dive into the details of, you have all this telemetry data, either across the customers or just based on one machine. And you can see trends, you can start predicting, and so on. So that's where machine learning, Hadoop, data lake, they come into place there. And then, of course, it's all about the connectivity. If you see something that fails, you typically want to integrate it. That could be just an SMS, but most of the cases, you will need integration with their ERP system or with their ticketing system, their case management. You want to maybe notify the right user in the right location and say, you need to create a service request in SAP, for example, so that you can start taking action. So that's all the integration. Sorry. If you then look at the effort we put into a project, we can see that most of the effort actually happens into the connectivity. So making sure that the devices, the things, the machines are getting their data into the cloud.
Do you mean man hours or
I talk about money, so man hours.
Yeah.
If that would be 100% of the total man hours, that would be an average. Of course, it's average, right?
I can see it's hand-drawn.
Yeah, that's why I have my Surface book since 2 weeks, so I try to do some hand drawing. I'm not that good yet, but so the connectivity is a very important part because that's where it all starts, but it doesn't add a lot of value. So I'm pretty sure that if partners and Microsoft and the industry itself using OPC UA and so on, if they can get that amount of time much smaller, everyone will be happy because it doesn't add value. It's just something that you need to get started with all the the right things. The second one is the collecting the data, make sure that you have internal routing, that you can filter out events. That's pretty easy with the default tools. Storing the data, it's mostly about okay, where we will store it, think about that, and then Azure gives a lot of out-of-the-box options. And then, of course, the analysis, that's where you do the analytics, that's where you can go very big. Most of the time, they just start with monitoring, so they are very happy with Power BI. Just seeing things from remote locations is very interesting for them. But of course, once that first phase of the project is ready, I'm pretty sure that all the effort will be put into 4 and 5. So they start maybe with a relatively small part of the project. With all the investments, they will happen in machine learning and predicting, in analyzing, in making insights from that data. And of course, the integrations. Now, first thing, connectivity. So if you think about connectivity, there's, in my opinion, 3 things or 3 ways where devices connect into the cloud in these scenarios. One is the direct connectivity, where the device has native connectivity towards their cloud backend, in this case Azure. Another one is a cloud gateway. So we have a lot of devices that come by vendors that have like an integrated connectivity towards a proprietary cloud of a vendor. Sigfox, LoRa, things like that, protocols. Most of the time they have a backend. And for us, if we then start to ingesting data from there, we need to talk with their cloud backend. So there we can forward events into Azure or whatever HTTP endpoint you want. And then, of course, we have the field gateways. And as I said, in the industrial scenarios, that's what we see most commonly used. So getting back to the direct connectivity, it's pretty easy to install. Once you have your machine working, it's very easy to install. But what we see is that it's sometimes hard for people who are writing, real machine logic in a language that is, in a total different manner. Think about PLCs and so on. For them, it's not that easy to suddenly think about, hey, and now we need to send data into that cloud. So they need to think about the retries because the HTTP can fail or AMQP channel could be closed and things like that. So they have to think about all that. They have to make sure that if commands or, they have to listen on multiple threads for commands and dispatch these commands in a loosely coupled fashion. For people that are into the machine development, that's not that easy. So what we see is that they are sometimes much happier to dispatch that effort to a team that does the IoT thing, and they will just talk on an existing protocol, and that's where the field gateway will come into place. And it also feels less secure. I'm not saying if you do it well, it's perfectly possible to have your machines directly connected using the service-assisted communication pattern, but it's definitely something that feels less secure for some customers. We don't want to have a direct connection with the internet, something you hear. So Azure IoT Hub is, of course, the service that comes with Azure to ingest all these data, telemetry data. Then the cloud gateway, I talked about that. When devices have their embedded connectivity. So I talked about the waste bin, for example, or track and trace sensors in trucks, for example. But most of the time, you buy such a device, and that device has a backend from the vendor. The vendor doesn't just want to sell his piece of hardware. No, they want to sell a subscription to you. So if you're building you're a truck owner and you want to have that track and trace service, it's not just the tracking device. You pay a monthly fee, but then that means that the data is into that that cloud backend of that device vendor, and they are providing more and more capabilities to push incoming events of that tracking system towards other ecosystems like Azure IoT, but also Amazon or your custom HTTP endpoint. So that's pretty interesting. And honestly, for us, it's an easy start because we don't have to look into the devices. We can immediately start receiving data from that other cloud backend, and all the connectivity ceremony is pushed to that vendor. So it's pretty easy to start. One of these customers we have is having an existing legacy protocol based on 3G or GSM connectivity with custom payloads, and they want to modernize their system into a real IoT solution, because security, for example, is something that's not built into their protocol well enough. So what we can use there is the Azure IoT Hub Protocol Gateway SDK. If I would click this one, you would see it links to GitHub. It's an open source reference implementation for MQTT, but you can build it towards any other protocol. So we will use it to bridge the old protocol to a real good implementation for Azure IoT Hub. But that will allow them to get all the legacy stuff from the protocol outside of the rest of their solution. And if they will build new devices, we will talk directly with IoT Hub. So we can support the existing stuff, but we can go with greenfield devices without the burden of the legacy support. That's pretty important. And then, of course, we have the field gateways. As I said, that's probably 80–90% of the cases that we come across in these scenarios. You have multiple production lines, multiple machines. You have one gateway that connects on existing protocols. That could be SNMP, could be file, could be HTTP, could be Z-Wave, Bluetooth, whatever. Modbus is commonly used. So you have a lot of different protocols. A lot of times it's all legacy stuff. We have customers that we need to connect to a SQL database. Go figure it out. And they typically install on one industrial PC box, typically not on a Raspberry Pi. And there, the machine logic is separated from an IoT logic. So if we need to do updates for the IoT connectivity, we don't have to bother the people that built the firmware of the machines and the other way around. And honestly, I think that's a good point. And it's easy to internet enable the legacy systems, if you ask me. You can just talk to their existing protocol, but make sure that it's internet enabled. And what we see there is that, for example, with OPC UA, that standard that I talked about, the gateway that we built for that customer, on the outside it will talk OPC UA, but we do the protocol translation into the legacy things like TCP sockets or SNMP for that customer. And that makes sure that at least they can start in workflows around OPC UA. For that, there is the Azure IoT Gateway SDK. Again, if I would click it, there's a GitHub sample. That Gateway SDK, and we're working very intensely together with that product team. The Gateway SDK is built on C, and I'm not a C guy, but the good thing is you can add your extension points, so custom adapters if you want, the configuration and all of that, and you can call it from C#. So there's .NET bindings, and it's it's an open framework. But what we did is make sure, and this might be a little small, but I will leave out the details. What we do is we have what we call the Nebulous IoT Gateway. That's a product that we built for customers, and we wrap in the green box. We wrap that Azure SDK. So we use that as a core because it's pretty solid. It's cross-platform supported, but we add a lot of logic to it because we want to turn that framework into a product. That product, for example, will make sure that we do real decent activation logic, that we do configuration updates from the cloud, that we can have a backend API where you can set different versions, that you can push remote updates to that thing. Because you have to understand, compared to, for example, building server applications, which we have been doing for 15 years, if something fails on the server or on your web application, it's pretty easy to patch it, right? You have the deployment capabilities and you have that server, you have access to it. When you have things in the field, that makes it harder. I cannot ask my customers, hey, we have a bug fix for the gateway. Please put your guys into the service trucks and have them updating the gateway at your customers. Or ask your customers to download this package and install it on all the gateways. That's not possible. At least not in a phase where you have a real production rollout on hundreds or thousands of machines. So that has to be, that has to support remote updates of the firmware or remote updates of the connectors, right? And that's pretty important there. So what we say, we add and wrap the SDK of Microsoft and we wrap it into a product. And a quick demo to show the concept without going into any details. This here is, let me zoom a little bit. This is my configuration portal. It's a beta portal where I have my gateway here selected, SAM dev PC. And if I will start my gateway, the gateway will go and retrieve that configuration from the cloud. The first thing it will do, it will check, am I already activated against my API backend? So it will do an activation check using a secret ID that is linked to this PC. So in a production system, that's something that's written on the silicon, something that you cannot see as a user, right? A secret key. And you will have an activation key of a user. And these two have to be matched. Then the device will be created into the cloud. It will be provisioned on IoT Hub, and the data will be, the credentials will be stored on the device. And as from then, you will be able to send commands, updates from the cloud directly into this this thing. This one, for example, listens on this to see if the ports are open. So this is just a demo. Of course, I would have Bluetooth connections, whatever needed for that specific device. So let me show what happens if I start. This is the console app. Of course, in the reality, we run it as a Windows application or as a Linux daemon or as a background task if it would be on ARM. So the first thing you can see is that the gateway is not activated. So it tries to activate itself using the secret ID that, of course, for debug purposes, I write on the screen. And then it does the call to the cloud. And you can see what happened since then. It got back the configuration from the cloud, and it started to listen on that specific channel. And it sends data into the cloud. So what is important there? If my customer suddenly wants to change something, if they want to stop or update or change this URL of their device because because that device has been moved or whatever, or they want to add new properties. They say, okay, there's a new version of that specific device, and I want to have the vibration of that motor read from this specific socket. They can update it in the portal, and they can say, and let's go here, sorry. They can update the configuration. I didn't change it now, but you can see that the configuration command is being pushed all the way into the gateway, and the gateway receives it and goes and asks for the specific new version. And this will be the case for everything. If we create a new type of connector, we will push it from the cloud into this system. And I will show later in the presentation what the device management capabilities are of IoT Hub. And there you will be able to say, please update all the devices that are, or all the gateways that are running version 1, or update everything that is installed at customer 5. So based on metadata, on tags, we will be able to push commands to the right gateways. Okay? Questions so far? Okay. So the next thing is the data. Data is not my core specialty, but it's a pretty important and a pretty complex thing. What we see, because we don't own the devices. You have the variety of devices. That also means you have a variety of data structures. Sometimes they have temperature in Celsius. Sometimes it could be in a different unit. Sometimes you have the volt of a battery or something. You have it in a volt or sometimes a millivolt. So it really depends. And if you want to do your data analytics, if you want to do machine learning, you want to make sure that you align everything together, that a temperature is a temperature, a vibration is a vibration, and the routes per minute, for example, are all in the same thing. So what we see is that once the data is ingested, we do two things. We store the native incoming message, most of the time in data lake. So we just dump it there because we don't lose data, and we can afterwards still have jobs on the historical data to retrieve data that we might have lost otherwise by normalizing it. But to do the real, like alerting, real-time handling, the business logic, we try to normalize the data structures that are incoming before we persist them into the relational or into the stateful processing of our chain. And that's important. Because that's one of the most complex things. It sometimes goes pretty technical and functional at the same time. One truck, for example, at one customer has 400 different types of sensors. It's not like we see with the scenarios where it's just temperature and humidity. Sometimes you have real hierarchies in a device. One device has different sensors or different components, and you can have 10 types of temperature. The temperature of this projector could be the lamp, could be the motor, could be the ventilation, and so on. So that's pretty complex to have. Then I won't zoom into this, and I won't dive into this, but if you click that link, it's quite an interesting blog post of someone of MTC, I think in New York, where he tried to make a decision tree on where should we store what data. And it's definitely not, the Holy Grail. I'm not always convinced by his logic, but it makes sense. So first of all, the thing that he says, okay, do we do real event processing? What typically remains there is the things like Storm and Stream Analytics. So that's for real-time, or what we call low latency, the hot path analysis, sorry. If you want to do the advanced analytics on unstructured data, there you have things like Hadoop, HD Insight, Data Lake. You might have seen the Hadoop session this morning. It's not that easy. If you're a pure .NET SQL developer, it takes quite a lot of time to get up to speed with that. What I liked, and it definitely has its disadvantages, but for us it was a good way to start, is the data lake analytics part. It combines SQL and C#, but it now also supports the other languages, I think Python and HD as well. But it allows you to write queries on unstructured data, data that can be residing in your file hierarchy. and you can do queries using C# and SQL. It's a strange mix. It's like select this from that, where x equals that, and the equals is not like SQL one equal sign, but it's a double equal sign like in C#. So sometimes you have the semicolon. It's case sensitive compared to SQL. So it takes some time to get used to it, but it's pretty powerful. So it's also the map reduce if you want. So they really spread the job over a lot of different machines in the cluster, and they combine back the results later on. Then, of course, DocumentDB and SQL are still a lot of times used, but for very cheap and large storage, I think table storage and even blob storage definitely makes a lot of sense. Now, the interesting part, and honestly the part where Microsoft Azure is missing an important feature, where we have to do a lot of development. That's why we decided to have a generic component now, is what I call the business rules. So you might have seen Stream Analytics already. So Stream Analytics allows you to do complex event processing, if you want, against a stream of incoming data. So imagine that all the stream of data from machines is coming in. You can just say, I want to get the average of temperature in a window of 5 minutes, and if the average is larger than a threshold, I will output it to something else. For example, to Event Hub, Service Bus, DocumentDB, Power BI. So it's pretty easy to start. It's pretty powerful, but it has its limitations. So for demo purposes, to do quick start proof of concepts, we very often use it. If it's a customer with fixed business rules, it's also powerful. But what we see, if you really need flexibility, if you need dynamic creation, on-the-fly creation based on a device, like this device has these specific rules, or I'm an operator and I want to create a rule for my devices now, that's pretty hard to do in Stream Analytics. So that's where we see Service Bus coming into the picture more and more, where we have a dynamic business rules, and typically we use reactive extensions using a query syntax, where you just can say, okay, my state of my lamp is now temperature 5, and if the incoming temperature is more than 10% off, for example, I will do an output. So that's not easy to write, but it's something that we really need in these more complex solutions, because the customer doesn't know his business rules up front. It's a business user that wants to say, this is for me important, and I want to get a notification in that case. And if you have to create a specific Stream Analytics query every single time, it would cost a lot of money, and it will be hard to maintain. So that's something that I hope, but officially there's no answer there, but something that I really hope that Microsoft will bring into their Azure platform. A powerful, dynamic business rules engine that you can use in a stream, but that you can very easily configure. Okay? And then, as I said, an IoT solution should not be isolated. If something fails, you want to take action. It's not just a monitoring platform. It's not just, hey, we have a Power BI dashboard and we're done. No, most of the time you want to have integration with systems. You want to send data back into the factory. You want to have your SAP updated with, like, you want to plan a maintenance ticket in the coming month at that customer, for example. So these things have to be typically integrated with the business processes of the customer. It's not remaining in an island on Azure. That's important. And what we see is that we often use Service Bus. I'm sure that most of you have seen and used Service Bus. The good thing is, I will show that in my demos, that there's also support now, what we call routes. So on the incoming telemetry, we can also filter and we can say, hey, if it's an event that contains a temperature, send it to that queue. And if it's an event that contains something else, send it to another queue. So we can do routing on IoT Hub without having to host a custom service bus, service fabric, or a custom function, or whatever you want. It's out of the box now. And then, of course, Azure Logic Apps. Some people might have seen it. It's a nice, interesting workflow engine that you can use to do enterprise integration and also lightweight integration, what they call citizen integration. So that would typically be used to connect to your SAP system, even if it's on-prem, or to send to your Salesforce in the cloud, and so on. All right? Then the important part is not just, once the solution is built, it has to be maintained, and the solution will evolve on the IoT side. So what we see is that the device management is a very important part. So first of all, you have plan, but then it's all about provisioning, making sure that identities are created, that the security is there, that you activate, that not someone at that point virtually acts as a different device. And then, of course, you have to configure. And as I showed with the gateway, you have to update configurations, you have to reconfigure, you have to change that, and you have to monitor. So this is the typical, active side of things, the bottom there. And then, of course, in the end, you might want to blacklist or retire devices from your solution for security purposes, or either because they are, customer is not paying his service contract, or the machine is moving or is being dismantled. What you need for that is scale. You don't want to update configuration machine by machine. You don't want to have that, in a closed system. So what Microsoft did was they looked into device management protocols like lightweight device management and so on. And you have to serve a lot of different roles. It's not just the operational guys, it's also the IT that is sometimes involved. Now, that brings me to the technical part of the session. And that's, of course, about Azure IoT and the different services that are in it. Before that, any questions? Okay. You probably have seen this picture, and it's already outdated, I'm pretty sure, because there are services being added every month to Azure. But this is an overview of the platform services, and what I really like when you build projects in the IoT space is that you have to use a lot of different services. This is the services that we used with our customers. As I said, the data, you have a lot of different choices. The analytics, of course, with IoT. As you see, the HD Insight is not something that we have used, but that's definitely valuable. So if there's one thing that I see powerful with Azure, is that, and that makes it complex at the same time, is that you have a lot of flexibility, you have a lot of choices. If your development team is skilled and your data science are skilled into the open source big data things, move them to Hadoop or HD Insight. If you have a .NET and SQL team, move them to the stream analytics and data lake side of things, right? Same thing with integration. If you want to do a quick start, go for functions. If you want to have more control on the state and on the, the orchestration side of things, you can look into logic apps. And if you want to really build solutions, you can look into Service Fabric for that. Now, little deep dive into Azure IoT Hub. So most of the people that have seen IoT Hub in the past have seen the telemetry demo, where you have one or more devices sending in data, telemetry, every second, every minute, whatever, into that queue. That part is what you will see in Event Hub as well. So if you've seen Event Hub, it's exactly the same. One big difference, every device has its own identity. So I can say that device X, Y, and Z, they all have their own identity, and I can revoke access for one device without infecting any one of the others. So that's where you start typically, sending data into that Azure stream, using MQTT, AMQP, and WebSockets, or HTTP, pure HTTP. But what they added was the concept of twins in the device management capabilities of IoT Hub. So a twin is something nice, and I think they looked at Amazon for that as well. It's a virtual copy of your physical device, right? So every physical device has a virtual copy in IoT Hub, and that contains tags. So you can add tags. As I said, if you deploy a device, you want to add some tags, for example, location. It could be a geolocation, but it could be just like, this is customer 15, and it's on the 3rd floor, or it's in production plant A. So tags are pretty extensive. So it's a JSON structure with maximum 9 levels of, depth in the structure. And then you have properties, and you have 2 sets of properties. You have properties that you can set yourself from the cloud. That's the desired property. So you can say this device should only send data if the temperature is larger than 20. So you will set threshold is 20. And then at the same time, the device can report the actual properties. So they can report the actual temperature at that point. You should not use this for telemetry. One thing that you can use it for example, is the version. The firmware version of my device should be 1.1, but if the reported version is 1.0, you can do a query, I will show that, against IoT Hub, and you will get back all the devices where there's a mismatch. And you can launch a job. You can say update firmware 1.0 to 1.1 using jobs. And the jobs will be here on the bottom. Okay? So I think I talked about most of that. The tags, the twins, the desired properties, the reported ones, and the jobs. So that will bring me to the demo, or the demos. But I have one question.
Do you still need to have hard-coded connection strings on the device to connect to IoT Hub? I think about a year ago that was still there.
So the question is if the device still has to have hard-coded connection strings. Actually, the device has to have a way to authenticate, and there's two ways. Either using the shared secret key, which is most commonly used, and then you have to store it somewhere. We typically don't store it on the device when it's provisioned. We get it from a secure way on the activation side, and then we store it. Most of the time, we store it in the TPM, if there's the secret module, the hardware module, and you can use certificates. Certificates are definitely a good thing, but they make it things a lot more complex. Management of certificates on server level is one thing, but managing certificates and lifecycle management of the certificates on devices is a different thing. And then, of course, you have to know the endpoint. So that also, you have to know the queue or the endpoint where you have to send to. So that's three things that you have to know. Okay? So the first thing I will show is the telemetry. And what I did, I built, because I'm really not a front-end developer, so the best thing I could do was switch from Windows Forms to WPF. I skipped Silverlight.
Developer design.
Exactly. It doesn't have colors at all. So this is my testing tool, where I will be able to show telemetry, file upload capabilities, device properties with the twin that I talked about, metadata, so I will be able to do a query, give me all the devices of location. Microsoft, for example, I will be able to do a direct method and schedule a job. So the first thing is telemetry. So what I will do here, and I will do the zoom here, yeah. This box on the right is actually starting up a thread, a separate thread, and the logging of that thread is on the right. So this acts as the server side, right? And if I will push a transmit button on the left, that will be a simulation of my device sending data into IoT Hub. So IoT Hub is between these two text boxes, if you want. So sending data here, you will immediately see the data coming on the right. At least that's what it should. No, because it contains an activity. I will talk about that. There's a route for it. You can see now my message is received on the right. Nothing fancy. This is really what you could do with event hubs from a message bus, from service bus. What I will do is I will move now to the routes. And that's a new feature that was added recently. So this is the Azure portal that we all know with my IoT Hub connected. And if I click here on the routes, first of all, let me click on the endpoints. So you can configure endpoints on your IoT Hub. In this case, I created one, and that's the activity topic. So it's a service bus topic. Here, a service bus topic on this service bus namespace. So if you're not, if service bus would be new with topics, a topic is a virtual queue where you can send messages to, and based on message properties, you can create subscriptions. So you can have on one topic multiple subscriptions, and you can say, if you're a subscription, I want to receive, I want to receive a virtual copy of all messages that match this specific filter. And you use the metadata for that. So you can have one message sent into a topic, and you can have 2 or 3 going to subscriptions. Not going into details here, but I created this endpoint. And what I will do now, I will create a route. Or actually, I have created a route. I have created the activity filter. And the activity filter says, is defined activity. So that just means if the message that comes in contains a property activity, then we have to route it to the service bus. Who has been using service bus? Okay, 25%. Could be 23. This is my service bus explorer that you might be familiar with. So there you can see I have 2 subscriptions. One subscription, for example, the SMS one, has a filter that says activity equals SMS, which is text messaging. So I will start listening on this one with a timeout of 30 or 20, whatever. And if I now will be sending data from here with the property SMS, we should be able to see the data coming out. That's because I changed activity to activities. So let's try that again. Start here. And you can see the message was received. I will send another one. So you can see my messages are now from IoT Hub being routed to a connected service bus. And there I have a lot of flexibility to do routing based on these properties. What you have to see is that now if I transmit, because I'm still listening on the right, if I transmit a message, the message is now delivered to IoT Hub because he has a matching route. And that means he's not delivering it anymore to the default endpoint of IoT Hub. So that means this thread that was listening is no longer receiving the messages. So if you want to have that, what you can do is just enable this filter that says 1 equals 1, enable it, and you have to route it to the events endpoint. I will not do it because of time, but then you would see that my message would be routed to service bus and to my listening thread. Okay? The next thing I will skip is just file upload, but just know that IoT Hub provides support for messages up to 256K, I think. Could be, yeah. Just, you can look it up, but it's not a lot. If you want to upload files, for example, we have that truck company. They want to upload files every now and then. There's a pattern in the same SDK. It's a claim check pattern. So you just say, I want to upload a file. You just do that using one line of code with SDK, but behind the scenes they are doing a post and say, give me a shared access signature to a blob. You upload it there, and so on. And then an endpoint gets notified, so you can have a listener that says, every file that comes in, give me the URL, and you can handle it. So that's pretty easy to do. Now, that brings me to the twin. What I'll do here, I'm loading the different devices from my my IoT Hub. And if I click one, you will immediately see that I'm downloading the device twin. So this is what that twin, that virtual copy in the cloud, contains. So it contains desired properties, which are in this case empty, and reported properties and tags. And the tags are even not there. Maybe I have tags here. No. So let's first create my sample devices. I will create 10 devices. 10 devices with some tags. I have different lights. I think I have 9 lights created. So let's do a refresh here. Hey, come on.
But did you delete the devices?
Did I click delete?
Yeah.
It was just to check if you were paying attention. So I should do this one. Thank you. So I'm fetching the devices now, and you can see that the devices are there. So I deleted them with some tags. For example, here, I now have a tag that says, sorry, location, building coded, floor tree, and priority is false. So that's just tags that I can use. You can use whatever you want. If you say the color green, it's, as I said, it's flexible, 9 levels deep you can go. So that brings me to the query capabilities. Where I'm capable to say, please give me all the devices where tags.location.building equals, and I will change it, for example, to Microsoft. And I do a query of the devices, and I can immediately see that there's a list of devices, and I get back their, their twin. So I see location, building, Microsoft, floor 7, and so on. Right? So that's pretty easy to do, and that will be used at the same time to do my device jobs. So a device job is different. The query that I showed was just give me the devices and you can iterate over them in your code and do whatever you want. Just show them in your management folder. But this is different. This is allowing me to set actions. In this case, for example, the desired state. Actually, my label is incorrect. This should be the desired state properties. So I can say for all the buildings that have location, or all the devices that are installed in the building Microsoft, please set the desired temperature to 30. And I will start the job. So starting the job is something asynchronous. You can see I'm polling every X times until it's completed or failed. So the job is scheduled, and it does the query against that filter, tags location Microsoft, and it sets for all these devices the temperature to 30. That means if I have devices now in building Microsoft, they will get that event triggered if they are listening for the desired properties, and they can say, hey, whatever they need to do, they call the TCP socket to update the temperature to 30, and they will say back to the reported properties, my temperature is 30. And that way, it's pretty easy afterwards to check, hey, indeed, I have all my devices desired and desired and actual temperature at the same manner. So let's do the coded temperature to 30 or 25, because we have to look after our money. And this should take some while to see the running and the updates as well. And then I will do the query here. Complete it. And if everything goes fine, the desired properties for, as you can see, for the coded buildings are 25, and for the Microsoft buildings, they are 30, right? And the other thing you can do with jobs is you can schedule jobs that, and it's like an orchestration of all the devices that happens in the cloud then. You can say, update all the firmware versions of the Microsoft devices. So the same thing I could do here with my job. Instead of just updating the properties, I could invoke what we call methods. So you can have a direct method. It's like a request response call you can do to a device from the cloud. So to do that, I can just say I will start my device, and again on the right here, this will be my thread of the device. So you see everything that happens on the device. And on the bottom, that's my server call. So you can see I am the device, and I started listening for the method get device type time. So one device can implement multiple direct methods. And that could contain update firmware, right? And I will now invoke the command get device time from the cloud. You will see that my device here has received that command and has sent back data that is now being visualized and handled in the cloud, and you can see the time has been sent back. All right? One last demo, and I will not run the demo because it took quite a lot of time, but just to use the cognitive services. I started yesterday. It was just to try it out. So what we have in the office, we have all these, pictures of everyone. That's mine. With the text, and of course with the picture of them. So I have some of them here, right? So I just uploaded these pictures into data lake, and then I ran my query, which is that uSQL that I talked about. And no worries, this is my last demo. So this is the only code I had to write, and that's that mix of C# and SQL. So I'm saying extract everything from that location in data lake using the image extractor, process the faces using the face detector, process the emotions, process the OCR, that's to extract the text, right? And then I join all these data sets together into a result set that I outputted here. So in the back of, this is what happens when I launch it. So all these jobs, every image results into a separate task for the cluster of data lake. That is, in the end, processing it again with the different, image recognition and so on. And in the end, I'm joining everything into the results where they were just outputted here. And of course, you can see that I'm pretty happy with the results of Azure because he makes me look pretty young and happy, as you can see. The good thing is that every gender was right, so we did not have females that were guessed as a male or the other way around. That made people happy. But quite a lot of people have, were pretty shocked in the negative sense as well. We have people that were 10 years older and so on. So still, it's a machine that wants to detect everything. Questions will be taken offline, I guess, because I'm running out of time. I'm also in the panel tomorrow on IoT. And now there's an interesting panel on compute and serverless. So I thank you for the attention, and see you tomorrow then. Thanks.